Now let us solve the question number 6 of exercise number 8.1. Diagonal AC of parallelogram ABCD bisects angle A. Show that it bisects angle C also, and also we have to prove that ABCD is a rhombus. Now in the question it is given that ABCD is a parallelogram and this diagonal AC bisects angle A, that is angle 1 angle 2 are equal, and we have to prove that it also bisects angle C. That means we have to prove that angle 3 and angle 4 are equal, and also we have to prove that the ABCD is a rhombus. So let us see what is given in the question. We'll write ABCD is a parallelogram. It is given in the question that it is a parallelogram. We'll mark it as equation number 1. Since it is a parallelogram, DC and AB will be parallel. Therefore, we can write angle 3 and angle 2. Angle 3 is equals to angle 2, as you know that it is forming a alternate interior angle. Similarly, angle this side AD and CD, they are also parallel. So angle 1 and angle 4, they will also be equal. The reason is they are forming alternate interior angle. Alternate interior angle. But it is given that AC bisects angle A. Therefore, angle 1 is equals to angle 2. Since it is bisecting angle A, so angle 1 angle 2 will be equal. Now, angle 1 is equals to angle 4 and angle 2 is equals to angle 3. So now we have proved that angle 4 and angle 3 are equal. That we can say that AC bisects angle C also. So we have proved the first part. Now we have to prove that ABCD is a rhombus. According to the definition of rhombus, rhombus is a parallelogram whose adjacent sides are equal. It is already given that it is a parallelogram, so we need to prove that the adjacent sides are also equal. For that, we will take the triangle. We are going to take the triangle ABC and triangle ABC. We are going to take these two triangles ADC and ABC. These two triangles we are going to prove congruent. Now in the question it is already given that angle 1 equals to angle 2, that is AC bisects angle A. AC bisects angle A. And if you see, AC is common in both. This side AC is common in the triangle ADC also and triangle ABC also. And also, this is marked as number 2 equation. Angle 3 is equals to angle 4. We have proved in second. Proved in second that angle 3 and angle 4 are equal. So now if you see these two triangles, so it is congruent by angle, then side and angle. Here also angle, side and angle. So the triangle ADC is congruent to triangle ABC by the rule angle, side, angle, congruence rule. Now since these two triangles are congruent, their corresponding parts will also be equal. So we can say that the corresponding part AD and AB are corresponding parts. So AD will be equals to AB. Corresponding parts of congruent triangles are equal. Now we have proved this mark as number 3. In the first we have proved that ABCD is a parallelogram, and in the third we have proved that AD and AB, that is adjacent sides, are equal. So according to the definition of rhombus, a parallelogram whose adjacent sides are equal is a rhombus. So we can write from first and third ABCD is a rhombus. So we have proved that the ABCD is a rhombus since we have proved that it is a parallelogram and adjacent sides are equal. Now let us solve the question number 8 of exercise number 8.1. ABCD is a rectangle in which diagonal AC bisects angle A as well as angle C. Show that ABCD is a square and diagonal AD bisects angle B as well as angle D. In this question it is given that the ABCD is a rectangle and the diagonal AC bisects angle A as well as angle C. That means angle 1 and angle 2 are equal and angle 3 and angle 4 are equal. And what we have to prove? We have to prove that ABCD is a square, and also we have to prove that diagonal BD bisects angle B as well as angle D. Now first thing that we have to prove is ABCD is a square. In the question it is given that ABCD is a rectangle. ABCD is a rectangle. We'll mark it as equation number 1. So now to prove a rectangle a square, we need to prove its adjacent sides equal. So we can say that the square is a rectangle whose adjacent sides are equal. So let us prove the two adjacent sides. For that we will take the triangle ABC and triangle ADC. And let us prove it congruent. Angle 1 is equals to angle 2. Angle 1 and angle 2, these are given in the question that they are equal, and AC equals to AC common. Angle 1 equals to angle 2, this is given in the question that the AC bisects angle A. Similarly, angle 3 is equals to angle 4. This is also given in the question, and it is given here. You can see AC bisects angle A as well as angle C. So angle 1 will be equals to angle 2 and angle 3 equals to angle 4. So now these two triangle ABC and triangle, these two triangles are congruent by the rule known as angle side angle congruence rule. So now since these two triangles are congruent, their corresponding parts will be equal. So in that case AD will be equals to AD. This is corresponding parts of congruent triangle and it is marked as equation number 2. Now in the equation number 1, ABCD is a rectangle and here we have proved adjacent sides equal. Therefore from first and second we can say that ABCD is a square. So now we have proved the first part. Now we have to prove one more part, that diagonal BD bisects angle B as well as angle D. That means we have to prove that angle 5 and angle 6 are equal and angle 7 and angle 8 are equal. This we have to prove. For that we will take the triangle, this triangle BAD and triangle BCD. BCD. We will take BAD, this triangle, and BCD, this triangle we will take. Now for proving it congruent, now since we have already proved that it is a square, so this side AB and BC, AB and CB both will be equal. We can write because adjacent sides of square are equal. Adjacent side of square are equal. Now these two sides are equal. Now AD and CD. AD and CD is also equal. That is due to the same reason that adjacent sides of square are equal. This side is equals to this side and this side is equals to this side. Now one more side is common, and what is that common side? That is BD. BD equals to BD common. So therefore the two triangles are congruent by the rule. BAD is congruent to triangle BCD by the rule known as SSS congruence rule. Now since these two triangles are congruent, so angle 5 and angle 6 will be equal, and similarly angle 7 and angle 8. Angle 5 and angle 6 are corresponding part. Angle 7 and angle 8 are corresponding part. So they are equal due to corresponding parts of congruent triangles are equal. So as these two are equal and these two are equal, we can say that BD, this diagonal BD bisects angle B as well as angle D. So we can write, therefore BD bisects angle B as well as angle D. This we have to prove.